Okay, so we're ready to go to slide number 1. I've set out 3 goals for the webinar today. The first goal is to confirm with everyone what the essential content for statistical inference on the AP syllabus is. Once we've done that, what I'd like to do is examine some ways that we might streamline our pacing as we go through the inference material. Finally, I'd like to spend a little time talking about some strategies for embedding AP exam review while we're doing this streamlining, because probably we're not going to have as much time after we finish the content as we would like. So those are 3 big goals. My plan is to take a pause at the end of each of these 3 components just to see if people have questions that you want to send along on the chat. And then as Cindy mentioned, when we get to the very end, we might have time for some general questions that weren't addressed. So here goes. We're going to go through essential inference content. I'm going to try to keep the first slide fairly brief, and then we'll do some drilling down as we look at the streamlining of the pacing. For me, inference actually starts with one of 2 types of problems. The first is estimating, trying to estimate some unknown parameter, and that's where we get into confidence intervals. And of course, the other type of inference that we're going to be dealing with is some kind of test of a claim, significance testing, hypothesis testing. That's pretty much all we do once we finish the unit on sampling distributions through the end of the course. And unfortunately, we don't have as much time left now as we'd like to do those 2 things. So within estimating and testing a claim, unfortunately, there's a long list of things we might estimate or test claims about. For instance, if we're trying to do inference about a single proportion, or if we're trying to do inference about 2 proportions, we're going to use some kind of procedure based on the standard normal curve if certain conditions are met. Or we might do inference about means. We could do 1 mean. We could do paired data, which is closely related to 1 mean. Or we could do 2 independent samples. And depending on which thing we're doing, we're going to be using some type of t-distribution, assuming certain conditions are met. Or we might be doing inference about categorical variables, a goodness of fit test with chi-squared, or a test of homogeneity, or a test of association independence. And then, with that little bit of time we have left, we might be doing inference about the slope of a regression line using, again, some type of t-distribution. If you just count quickly how many different things we have to estimate or test claims about, you'll probably get a little background. We'll probably come up with somewhere north of 10 different inference procedures that we have to help students learn. But my logic is we don't want to worry about mastering each procedure in great detail until we've got the big ideas down. With that thought in mind, those of you who've looked at the AP exam rubrics for free response questions may have noticed that they typically follow a four component or 4-part structure. The first part has something to do with defining parameters. In the case of hypothesis testing, it means setting up your hypotheses and often being asked to define the parameter in context. If you're doing a confidence interval and trying to estimate something, then you're identifying what the parameters are that you're going to try to draw conclusions about. And if the students do a good job of defining their parameters in that first component, I find that they have a much easier time in the conclusion piece because they'll restate the parameter that they defined in the first component. In between, though, we've got some conditions that we need to check to be sure the inference method is appropriate. We need to do some calculations, and then we need to draw our conclusion in context based on the calculation that we did. So what I'm going to try to do is continue to mention that 4-part structure. Until last year, it had always been the case that on inference questions that focused on a confidence interval or a significance test, each of those 4 components was awarded one of the 4 points on the holistic rubric. And again, until last year, each of those 4 components was scored as either essentially correct, which got you 1 point, or as incorrect, which got you nothing. So for example, if you were checking conditions and got a little bit right and a little bit wrong, that would score incorrect. Thankfully, last year, the adjustment to the scoring was made to give partial credit on different aspects of the inference problems. So student scores, not surprisingly, were not only better, but probably more accurately reflected what they knew about inference. So if they can master this 4-component process, they have a much better chance of scoring well on the exam. And the final thing I want to bring up now is I think it's really important that you help students distinguish between inference when random sampling is involved and inference when you're doing a randomized experiment. Recent exams have really started to focus on this distinction and the fact that random sampling allows one to generalize to some larger population of interest, while random assignment in an experiment allows us to establish cause and effect kinds of conclusions. So we don't want to use fuzzy wording in inference problems. We want to be clear on whether we did random sampling and we're trying to generalize, or whether we did random assignment and we're trying to establish cause and effect. So those are the big ideas, and the case I'm going to try to make is if we can emphasize the big ideas up front, we're going to save ourselves a little bit of time as we move through. All right, so other than my face blocking the W and no on my screen, all the inference you need to know. So we've mentioned there's estimating and there's testing a claim. So here are the 2 generic formulas that are provided on the AP exam formula sheet. Students need to be comfortable with these sterilized versions because the ones they see in textbooks have little symbols plugged in all the right places. But on the AP exam, they're left with these generic forms, and on the formula sheet, they're given these what are called standard deviations of statistics. Well, the student's supposed to know which of those standard deviations of statistics to substitute in the appropriate place in the computational formula. So for instance, if they're doing a confidence interval about a single proportion, they're supposed to know to use the sample proportion as the statistic, a z-star critical value if the conditions for normality are met, and then the appropriate standard deviation that comes from single sample proportion. It's a non-trivial exercise for those of you who've gone through this to get kids moving from textbook formulas to this more generic formula sheet. So I like to practice early and often with these very sterilized versions because I think it helps them on the exam. This is basically what my kids are going to see on an in-class test as well, because I want them used to this format and this unusual way of presenting the standard deviation of the statistic for them to think about. I mentioned earlier the 4 components of the inference rubric on the AP exam. What we've tried to do in the 4th edition of the Practice of Statistics is develop a problem-solving strategy that mimics that 4-part process, but that also fits with things beside inference. So we're calling it state, plan, do, and conclude, and it even has a catchy little background acronym that you might be able to keep track of, a little saying, statistics problems demand consistency, state, plan, do, conclude. So my kids have seen this all year and are kind of used to it by now. There's either a chuckle or a grimace every time we see one of these 4-step problems. And you can see in parallel, if you think about the 4 components of the inference rubric I mentioned, the state part is about the parameters, the plan part is about checking the conditions that are required for doing that inference method. The do part is what the kids love to do. That's the part where they do the calculations. And the conclude part is really where you interpret in context. Although kids love the do part, it's only worth 1 point of the 4 available points. So I'm here to argue that it's probably the thing we ought to spend the least amount of time on, and yet early in my teaching of the course, I tended to spend quite a lot on it because it was the most mathematical. There were pretty formulas and numbers to plug in, and you could use your calculator. Only there's that whole stat test menu that pretty much makes the calculation part obsolete if all we're trying to do is get to the answer. So a little thought for you. So we've got the 4 components of the inference rubric. And then this issue of scope of inference I was mentioning before. Random sampling means you can generalize to a larger population, the population from which the random sample was taken. And in a randomized experiment, we're allowing students to infer cause and effect. But usually in a randomized experiment, the subjects are not randomly selected from some larger population, so you're not able to generalize to just everybody. You can only generalize to people like the ones who took part in the experiment, often volunteers. All right, so I'm going to pull up a quick little summary chart here. We'll see how technology does as we transition from the PowerPoint to the summary chart. So Cindy will give me the signal when the summary chart pops up.
Just came up with the summary chart.
All right, we're getting closer, but we're not quite there. Cindy's giving me a slow nod. Slow nod. Okay, so we have a summary sheet popping up. This is from the back matter of the 4th edition of the Practice of Statistics. And you've seen the state plan do conclude before. You've seen the sterilized formulas. This is the part where you try to link what you're doing in the textbook to the sort of sterilized versions of the formulas up above and to the AP formula sheet. So you can see here really a summary of everything that we need to do with the students that's part of inference. So let's see if we can keep count here as we go down. So starting with proportions, we've got estimate or test for 1 sample. So that's 2 methods that we need to talk about. For 2 proportions, we have the estimate and we have the test. So we're up to 4 now. 4 methods involving proportions. On the back of the page, we've got means. And now the counting gets creative because if you have 1 mean, we've got an estimate and a test. So that brings us up to 6 total methods. If you count paired data as a separate kind of procedure, you could even argue that we're now up to 8. I like to think of paired data as just a special case of the 1 sample problem, though, so let's keep it at 6. But you do need to deal with paired data, or kids start treating it as if it's 2 independent samples. So I'm at 6. We have 2 means, estimate and test. Now we're at 8. Then we have the distributions of categorical variables. That's your chi-squared. And again, we can do creative counting. The goodness of fit test is clearly number 9. A lot of us would argue that the test of homogeneity and the test of association should be thought of differently. So we have 10 and 11. And then the one we always celebrate when we get to is inference about slope. And we have estimates and tests there. So I'm at least 13 methods that we need to keep in mind and we need to address, and maybe 15 if you count paired data separately with the estimate. But even if you just spent 1 day on each method, you're at 15 days. And that's just dealing with formulas. Sorry, we got a little background there. All right, so I'm going to toggle back into the PowerPoint here. That was our summary chart. Oh, in case you were wondering, the little flamingo in the bottom corner of the slide is sounds like we just had an explosion out there. We're gonna kill that sound. The flamingo is from the front cover of the edition of the Practice of Statistics, which is one of our nice cover pieces. So that we're going to try to mute you. That completes the first part of the presentation, which is just the summary of the inference content. So I'm going to pause just for a second to see if anyone has a clarifying question. I'll let Cindy wave at me if anyone has any questions just about the content. And then we're going to get into the streamlining part.
And again, you would send your message to chat in the bottom right. If you see up at the top, it says Viewing Daren Starnes Desktop. You would click on that blue bubble that says chat if you want to reach out to me and ask Daren a question about inference. Anyone?
I feel like Ferris Bueller. Anyone? Anyone? Bueller? Okay, I'm going to move forward because I think this next part is what you all really came for. This is the part about streamlining, and I'm going to get real specific. I don't think you want generalities from me at this point, so we're going to do the general suggestions because I think that you'll see how I've woven them into the pacing that I'm about to show you. My very first suggestion, which I have hinted at already, is to really focus with your students on the concepts and not spend a lot of energy on the formula development. We're in a hurry, and we want them to understand the ideas of inference. It doesn't bother me at this point if I'm behind if a student is doing most of the calculations using stat tests or the equivalent on their calculators. It really doesn't bother me as much. So that'll save some time if you're willing to allow more in the way of calculator technique. And my other general suggestion of a big nature is to front load several big ideas as you're introducing confidence intervals, to get kids thinking that a confidence interval is an interval of plausible values for the parameter, period. If you can get that one idea across, then they'll have a much easier time interpreting intervals later. Second one is helping them understand the difference between interpreting that confidence interval, which gives the set of plausible values for the parameter, and interpreting the confidence level, that 95% business. If you can get them thinking of the confidence level as a capture rate, a long-term capture rate of that method. The problem is that the students want to assign the confidence level to the specific interval they just calculated, and that's a disaster anytime they try to do it. Conditions for inference, I think we all know that those are being stressed quite a lot. And we want to make sure that students, as they're doing inference about proportions or means, check the random condition, that the data are produced either by random sampling or random assignment, that they check the normal condition, which depends upon exactly which procedure they're doing, and that they check something about independence, which may involve sampling without replacement, or it may involve independence of groups if you're doing two independent samples. So the random, normal, and independent get us through all of means and proportions. And then, of course, things change just a little bit when we get to chi-square. I saw a pop-up message just now from Jeremy. Jeremy, if you could send your request back to Cindy. I saw your question pop up, but it disappeared off my screen before I was able to answer it. So we'll try and get that answer for you. All right. So conditions are huge.
Can you repeat that about CI?
Yeah. So request to repeat the comment I made about the confidence interval. So the confidence interval is the set of plausible values for the parameter. That really helps when students are thinking of doing a significance test also, because they can look at the plausible values of the parameter from the confidence interval and see if the null value is in there. When interpreting the confidence level, we want them thinking about the capture rate of the method. We don't want them to mix the two. In fact, when my students do a confidence interval free response question, I don't ever expect them to interpret the confidence level unless I ask them to. I've instructed them not to try to interpret the confidence level unless they're specifically asked to, because they'll start marrying the two interpretations together in really bad ways. On significance tests, there are three things I've identified there. One is just the whole logic of significance testing. Many of us use the court of law analogy that the null is that the defendant is innocent and that the alternative is that the defendant is guilty. But when you render your verdict as the jury, you don't come back and say, we, the jury, find you innocent. This is the not guilty part. And so it leads into the rejecting the null and failing to reject the null. Court of law logic. The next thing I've highlighted on statistical significance testing is the concept of a p-value, that the p-value is really a conditional probability under the assumption that the null hypothesis is true. It's really important that students understand that idea, and that the p-value measures the likelihood of getting a sample result as unusual as or more unusual than the one we did in the direction specified by the alternative hypothesis if HO is true. We have to start with HO being true. We also debate whether we should have students do their conclusions by interpreting the p-value or by using a fixed significance level. And I'm going to go out on a limb here and perhaps cause some stir, but I really think if you want students to perform consistently well, you're well served to have them set a significance level as part of the beginning statement of the hypotheses. So my students will do the state step. They'll give the hypotheses and the parameter, and they'll go ahead and they'll set their significance level right then. Okay.
I'm a first-year teacher of AP. Do the students have to show their work on the calculations, and to what level?
All right. We're to the do part now of the calculation. Students are required to indicate what method they are using, either by name, such as one proportion z-test, or by formula. So they can show the computational formula for the one proportion z-test that they're doing. Z equals p hat minus p naught divided by the square root of p naught times quantity 1 minus p naught over n. So they can show it by name or by formula. Students who are computationally challenged or teachers who are time challenged might be well advised to have students write one proportion z-test and then have them hit the stat button on the calculator and do all of the work through the one proportion z-test menu. All the student has to do is write the name of the procedure and then write down the result of the calculation in the calculator. There is a risk of using only the calculator and not showing the formula with the values substituted in, and that is if the student makes a mistake in entering something into the calculator, there's really no scope for partial credit. It is risky in that sense, but from my experience working with my students, it's less risky to do that than it is to turn them loose with some of those complicated formulas, say for a two-proportion test. So all that we require on the AP exam is an indication of the method that you're using by name or by formula and the result of your calculation. If you want the opportunity for partial credit, you do have to show numbers substituted into a formula. And my students understand the risk they're taking. There's also the difference between what you require on your classroom work and your quizzes and tests and what you're coaching students to do on the AP exam, especially as the time runs out. My final bullet there is about the concepts of type 1 and type 2 error and power. I really like to bring those in from the very beginning, from the very first time we do a significance test, to have kids talk about what could go wrong. What could go wrong if the HO is actually false and we don't pick up on that? What could go wrong if the HO is actually true and we fail and we reject that HO? And which is more serious, and what implications does that have for setting a significance level? Because we want them to figure out that the probability of making a type 1 error is equal to the significance level. And then the connection to the power of the test to detect a difference if one really is there, and what affects power. So we just finished doing that actually in my class about 2 days ago. We've just started on significance testing for one proportion to give you some idea where we are right now. We have a question.
How do you decide on a confidence level prior to computing the p-value?
Okay, so in a significance test, I have a little background noise there. In a significance test, one of two things will happen when students are presented with the problem. Possibility number one is that they'll be forced to use a particular significance level by the question writer, and this happens some half of the time or more on the AP exam. The other possibility is that they'll not be told a significance level and they'll just be asked to run the test. What I've advised my students to do in that case is to go ahead and set a significance level at the beginning of .05 as a default. We can blame R.A. Fisher for .05. That was his idea, but a lot of us thought he was pretty smart, and so we just do it. If they're willing to take time to consider the probability of type 1 error and its seriousness and the probability of type 2 error and its seriousness, then I'm willing to allow them to pick something else for alpha. We've had problems in class where students say, well, I don't want to use .05 since you didn't specify. I think it's pretty serious to make a type 1 error, so I'm going to use .01. That student clearly has it, and they're welcome to use .01 for that reason. I think I see a note coming in from Joy on my screen. It pops up on my screen, but then it disappears. So Cindy will have that in just a second. My final bullet there is related to the comment I made about using technology for the do step. This is a big time saver, particularly with students who struggle with algebraic formulas, and especially when you get to 2 proportion z-tests and 2 sample t-tests where the computations are really quite complex. More students are going to be able to get it right with the calculator commands. All right. We'll have a few more comments coming in, I'm sure, but it's time to get down to business. I promised some streamlining advice. So here's my goal. I'm going to try to show you a way to get through, and I do mean get through all of that inference in 32 class days of approximately 50 minutes each. If you're on a block of some kind, you have to modify accordingly, but class length of about 50 minutes, 32 total days. I feel like I'm playing Name That Tune now. I can finish inference in 32 days. Well, I can do it in 31. To be honest, in an ideal pacing situation, I allow myself 36 class days to do it. So this is an even more streamlined version than I like to do, but that's sort of where we are this year. So I'm going to give you the 32-day version, and maybe even mention 1 or 2 more days I could pluck off if I didn't even have 32. So hopefully nobody's moaning now and saying, I've got 26. So I'm going to take up your first 6 days on confidence intervals for a single parameter. And I'm going to give you a drill down look day by day. First day, what is a confidence interval? What are the conditions? Hopefully we've already foreshadowed some of the conditions when we were doing sampling distributions for means and proportions. And there's that key idea of interpreting the confidence interval itself as an interval of plausible values versus interpreting the confidence level. Day 2 is where I introduce confidence interval for one proportion, how to compute that, how to lay out the work, and how to determine the sample size for desired margin of error in the planning of a study, actually calculating the sample size if you know the desired margin of error. So they get 1 day on estimating a proportion. Then we have to spend a little extra time when we don't know the population standard deviation and are trying to estimate a mean. And by the way, that's almost all the time. If we don't know the mu, we don't know the sigma either. So we talk initially about how to determine sample size that's appropriate using a previous study that we've run as the hypothetical value of sigma, because we need some kind of estimate. And then we immediately say, what happens when we take away sigma being known? And that leads into the t-distributions. But then an entirely separate day for us is calculating confidence intervals for a single mean, going through the 4-step process for estimating an unknown mean. On day 5, I like to give them time to digest all of this in an assortment of practice problems that we do together in class, sometimes in small groups, sometimes on their own, or check with their partner. But we need a day to consolidate and for me to monitor their work. More and more, I'm finding that students on the homework are not as focused just on my work as they might have been in previous years. There are other distractions for them. And so if they're in the room, I can actually see what they're doing and I can give them feedback on the spot, or their classmates can. And then day 6 is my assessment. So one of the things that you can pick up on here is whether I'm building in an assessment as a full day and a review or practice. I do think the assessment part is important for them to really be forced to consolidate it before they move on to something else. But then we can spiral a few things as well. So there went 6 days for confidence intervals for a population. Remember, goal is to get this into 32. So now we turn to significance tests for a single population. That's going to be for means or proportions. And you see there's a little more time for this area than for confidence intervals. Testing is more complicated. For instance, we have all of the underlying logic, how to state hypotheses and how to interpret the p-values, and what statistical significance means, what a significance level is, and how to compare your p-value to it. For me, those ideas are well worth a day. And another day that's well worth it is the types of errors we can make with tests and how to get the most power out of a significance test. I'm front-loading big ideas. That way we can use them all the way through the unit. Then we get into the actual tests. 1 day for running a significance test for a single proportion, one-sided test at this point, going through the 4-step process. And then on the second day of working with proportions, 2-sided tests. And I've subtitled this, Why Confidence Intervals Give More Information, also to show them that the confidence interval for a proportion and the significance test don't perfectly agree. The standard deviation of the statistic that's being used in each calculation is slightly different because you're using the null value for the test and you're using the sample proportion for the confidence interval. That brings us to the one sample t-test. And then we need to deal with situations where the data are paired and we need to calculate the differences. And I've added things about using tests wisely here, just the sort of mistakes one can make if one isn't careful. There's my review, consolidation day, practice problems, lots of discussion. It's amazing how focused the kids are on that day. And then day 8, an assessment, testing them on significance tests. So I've burned up 14 of the 32, laying the foundation and doing things for one parameter. And I promise it's worth every minute. Because, interesting. Remember our goal is 32 days. So sorry, the symbols have already popped in. We're going to do comparing 2 groups or populations now, because it could be a randomized experiment or it could be random sampling, 2 independent random samples. So the first day is looking at differences in sample proportions and how the sampling distribution of that statistic is related to combining random variables from before. So for the math people among us, we can spend a little time deriving things. And then time to do the confidence interval with the 4-step process. Day 2 is totally dedicated to significance tests for the difference between 2 proportions. And I do specifically talk about inference for randomized experiments, separate from inference when you're doing random sampling from 2 independent samples. Third day, we've got to do the estimation for the difference in population means. So we have to talk about the sampling distribution of x bar 1 minus x bar 2. And then on day 4, we run significance tests for mu1 minus mu2. We have a question or comment. Oh, we have a pause.
We have a pause now. Day 4 just came up.
Okay. Sorry, I'm running a little fast there. Day 5, I'm already to assorted practice problems. You've kind of got the routine now. Means and proportions are mixed throughout, and that's something that really, over the last 8 years, I've found extremely successful, having kids being forced to distinguish between whether they're doing categorical data or quantitative data all the way into the exam where the problems are going to be mixed. And then day 6 of this unit is our test on the 2-sample methods. We have confidence intervals, we have tests, we have proportions, and if you're really, really, really into spiraling or just really mean like I am, you might throw in a 1-sample inference problem on your 2-sample test. Happens for me every year. All right, so there went 6 more of your days. We're going to need some time for categorical variables. This is your chi-squared material. So the first day I spend developing the chi-squared statistic and the chi-squared distribution and looking at the fact that it's right-skewed, and so we're not going to have a normal condition here in the usual sense. We're going to have some kind of other condition that involves large expected counts. Day 2 is where we actually go through the 4-step process on a chi-square goodness of fit test, and then if we find a significant result, we do a follow-up analysis to look at the individual contributions to the chi-square statistic. On Day 3, we go to the test for homogeneity, where we're comparing independent samples or groups. We're looking at the distribution of one categorical variable across several populations or several treatments in a randomized experiment. So the data have to come from independent random samples or independent groups in a randomized experiment. And then Day 4 is looking at one population of interest, one random sample drawn from that population with the individuals classified according to 2 categorical variables. So we're looking at the relationship between those variables using a test for association or independence. Day 5, you got it, assorted practice problems, all these different chi-squared things. And of course, this is your chance to talk to students about the fact that a 2-proportion z-test and a chi-square test for homogeneity have a really clear connection. The square of the z statistic from a 2-proportion z-test is equal to chi-squared. So you can kind of sneak that one in the door and also do a free 2-proportion z-test. You could even do a 2-proportion z-interval as well and do a little bit with estimation. And you've probably guessed what Day 6 is. So for those of you keeping track on your scorecard, all that's left is inference about slope. And usually we're rushing. So now the confessional part. A few years ago, Josh Tabor and I started corresponding about the fact that we hated that unit on inference for slope. It always felt rushed, and it was always too small. It was really just a couple-day, 3-day unit because we had to build up to the idea of doing inference for a slope and repeated random sampling or random assignment. So look at this unit carefully, and you'll see the little bonus prize at the end. Conditions for regression, the idea of the inference for linear regression model, confidence interval for the slope. That's plenty for the first day. Day 2 is where we do the significance testing for the slope using H0 beta equals 0. And then here's the little surprising part. For those of you who have already done this, you get some free days back. We've chosen to postpone transforming data with logs and powers until the end because we tend not to use it very much in the middle of the course, and our students aren't terrific with logarithms. So we do the transforming with powers and roots and the transforming with logarithms right here. Build in a few practice problems, and it keeps the rhythm of those other units. But as I say, good news for those of you who've already done it, you're down to 30 days. We made it to 30. So I think I just streamlined it. 32 days, or if you're lucky, 30. A couple of other thoughts about pacing. This is a very strong suggestion when we're in the inference section. Do more with less. Assign fewer homework questions, but make them really good quality. My assignments during this first couple of units, we've done confidence intervals, now we're doing significance tests for one parameter. It's rare that I have more than 4 homework questions. The only reason I would is if there is only one 4-step inference question, and that's never going to happen. They're going to have 2. So if they have 2 of those, that's a lot, and I'm just going to have 2 conceptual questions with it, or 1 conceptual question and 1 review question from a previous unit. Another suggestion, again, focus on interpretation. It's too tempting for us as math teachers to spend time on the computation, and in the reward scheme, that gets them 1 of the 4 points. So it's a terrible thing to spend 50% or more of our time on the calculation when it only nets them a quarter of the value on the AP exam. Plus, we just want them to understand it. That's important. They'll take that away. And therefore, having them use the calculator functionality can be a real help. Not that you shouldn't show them the computations, but allowing students to use this as a little bit of a crutch while they try to master some of the details. All right, so that was our big unit. This last one is sort of my afterthought on AP exam review. So I'm going to pause just for a second to see if anyone has any questions or comments about the streamlining part, your 30 or 32-day plan, anything you want to ask.
And remember, if you're not seeing the chat box, you can pull down the green bar at the top of your screen, viewing D. Starnes desktop, and click on that blue bubble chat, which will bring down the chat button, and you can type in either sending to everyone or to D. Starnes, presenter, and we will get your questions answered. Any questions? Do you have a set way to write the interpretation of the confidence interval?
Yes, definitely. My students get enough practice with this verbally in class, putting homework problems underneath the document camera to critique one another, watching me do examples. They're going to say something very similar to, we are 95% confident that the true proportion of people who text while driving in New Jersey is between 0.47 and 0.53.
And there was a question on the rubrics. Do you think there is a chance that the rubrics might get tighter and require some support for computations now that we're giving partials on inference questions? At the very least, do you think having support for the test statistic or confidence interval might weigh into the holistic scoring?
That's an excellent question, and I applaud
Gloria.
Hi, Gloria. I applaud Gloria for asking that one. I do foresee the possibility that with the partial credit now being available on each of the components, that there might be more emphasis placed on students being able to substitute the correct values into the correct places in the formula. So I hope Gloria and everybody else didn't hear me say not to do the formulas. But I do think with students who have more trouble with the computation, they at least have a chance to get an answer that's correct and interpret it, whereas if they use the formula, they might not be able to do it. But I absolutely try to get each of my students to use the formula correctly, substitute the values in the right places, and then as we get into the AP exam review, I'll show them the calculator techniques and remind them that if they're stuck, if they're having trouble, please don't write down horribly wrong formulas when the calculator is available. Thanks for that one, Gloria.
And then on a typical day when you introduce something new, do you work through a lot of examples or do you emphasize the concepts over the formulas?
That's a great question. My students are used to a format. We have roughly 50-minute classes. We tend to spend about 15 minutes on homework. Again, we have about 4 homework problems. So the 2 where they have to write out work, we typically stick a randomly selected student. What else? Randomly selected student's paper under the document cam, and we do live critique. I just sit there quietly and let the kids give feedback about what they think is done well and what they think could be done better. The student is able to defend themselves if they wish. So we do those 2 problems, and then the other 2 we have a class discussion about. Those are the conceptual ones, understanding type 1 error, type 2 error, connections between confidence intervals and tests. And that leaves me about 35 minutes to introduce the new material. I want to be able to do 1 4-step example in each class when we're doing the different methods. And so that's going to take me a good 20 minutes for sure. And as they ask more questions, it might take a little bit longer. If there's any background material that I need to put first, we'll do that. But usually I like to either work through an example myself, or if we're on the second day of a topic, I might give them the problem, give them about 10 minutes to work on it before I jump in. So they do see me work 1 full example on the first day of any of these topics. On the second day and on those practice problem days, I want them doing something, and I give them feedback. Good question. All right, I'm going to head into my third part here, and then we're going to take some time for questions that come up. I mentioned that I was going to suggest some ways to embed AP exam review as we're doing this race to the finish. And one way of doing that is anytime you encounter the details of the study design within an inference question, take the few minutes there to have kids talk with you about whether it was an observational study or an experiment. Was there random sampling or random assignment? what scope of inference does that allow for us? And then if it was an experiment, you can drill deeper. You can ask about the experimental units, the treatments, the explanatory variable, the response variable. You can get a little overexcited about this and forget that you're doing the inference problem, but it really is productive to have kids practice using the language from earlier in the course, because we know that that's going to come into play on the plan step when we're looking at conditions, and it's also going to come into play on the conclude step when we do our inference either about a population parameter or about cause and effect. I also recommend that when we're doing these inference questions in class, especially, that we give students the opportunity to see data analysis done. If it's categorical data, we look at counts and proportions, and graphically we look at bar graphs, comparative bar graphs, maybe a pie chart, but maybe not. If you've seen my pie charts drawn, you would keep me to a bar graph. And then if we're dealing with quantitative data, we want to look at graphical displays, some of which we're doing to check for normality, but some of which we just want to do as part of data analysis. So you might do this before even launching into inference, if the time is there in class. And then I mentioned that sometimes, particularly on the second day of a topic, I try to throw in one or two questions from the earlier chapters in the homework, not because I want to go over it again, but because I expect the students to be able to look back if they don't remember, ask other students, and do some spiraling. Sorry for the promotional plug about a specific set of flashcards, but I do use Daren's flashcards from time to time when I have a few spare minutes at the beginning of a class, at the end of a class. If we kind of reach a dead spot somewhere in the middle between things, we'll use some flashcards and do some practice questions. And then my kids don't love me for this until the exam, but the night after the test, they know they're going to get a cumulative assignment, and it's going to be some kind of AP style, either free response, multiple choice, or a mixture. They know it's coming. It's, as I say, along the way, it's not their favorite thing, but as we get closer to the exam, they see the benefit. Oh, wow. That third part was short because I want to make sure you have time for some questions. Cindy's been accumulating them over there. And just a message that I wanted to send too. Remember, you really can get there. You may not get there without them kicking and screaming, but you can get there. And the other thing I want to invite, if there's something that we don't get to here in the question stage, and you want to follow up with me, I'm really good with email and glad to respond. I enjoy corresponding afterwards, something that you've tried and been successful with. I'd love to correspond with you after the session. So feel free to email me. It might be tomorrow before I get back to you. I think my wife may have tonight called for, but.
So there were a couple of questions about the interpretation of the confidence interval, and I guess the audio cut out for some people, and just clarifying about showing work for inference. Okay,
so let me start with the interpretation of the confidence interval. I gave an example a few minutes ago in terms of the sort of generic format. My students are going to say something like, I am 95% confident that the interval from 0.58 to 0.63 captures the true proportion of people in New Jersey who text while driving. Now, for those of you that listened really carefully to me earlier, you just heard me reverse the two pieces of the confidence interval statement, and that's because either one is acceptable. But I'm also trying to appeal to the people out there who are using the third edition versus the fourth edition, because we've made a change in the ordering of the confidence interval interpretation statements to try to help the kids remember that the parameter doesn't change. The parameter is fixed, and we really want them focused on the fact that the interval that we've calculated, we've done so because we think it has a chance of capturing the parameter before we calculate it. So the confidence interval interpretation stops there. We don't mention anything about what the 95% means unless we're asked about the confidence level. Other one, Cindy, was about...
showing work for inference. Just to clarify, students should show both test statistic and calculator command, like normal CDF?
Good question. What's required on the do step for a significance test, number one is the test statistic. either Z or T, and any associated degrees of freedom, if you're ZT chi-squared, degrees of freedom that you're using, because you could be using a technology-based degree of freedom, or you could be using a simpler, more conservative one that you do by hand. And the second thing that's required is the p-value, test statistic and p-value. There are very few people out there who still use rejection region approaches to hypothesis testing. That's certainly acceptable, but it's not as common now. So test statistic with DF, p-value, that's all you need for the do step, which means if you've named the procedure and done those two things, you're good to go right now.
And when do we test for means from sample data? And when we do a test for means from sample data, must the student sketch a graph of the sample data for the normality condition?
Yes, you must. Thou must check thou's normality. Remember, if the data are provided, if you have quantitative data sitting in front of you, you're expected to do a graphical check of the data. You're looking for outliers, which are a big problem for the T procedures. T procedures aren't very robust against outliers. And you're also looking for really strong skewness. To be honest, on the AP exam, if they're asking students to do an inference question, they expect them to do the inference question. If they want to check whether they know about conditions, and that's all they want to know, then there's a separate question about conditions. But at least thus far, we haven't seen, nor would I expect, any kind of do an inference problem where there was some tricky little weird feature in the graph. But I do think students overreact sometimes to how non-normal the sample data can look when you sample from a normal population. I do an activity with my class where I have them actually, each of them take a sample at random on their calculator using rand norm from a truly normal population with a fairly small sample size, and then make a graph of the sample data. If you haven't done it, it's quite remarkable how bad those samples can look. But once they've done that exercise, they're much more willing to look at a not perfectly linear normal probability plot, or a not perfectly symmetric histogram, or some slight skewness, and say, yeah, that could have come from a normal population, no problem.
They have to show a graphical display of a normal probability plot, or can they just say the normal probability plot is linear, thus the data should be approximately normal?
All right, so I'm going to make a point. Normal probability plots are not on the AP Statistics topic outline. Students are welcome to use them, but they're never expected to, so I don't want anybody out there thinking, oh, I haven't covered what's normal. I don't do normal probability plots. If you're checking normality with the quantitative data, you're expected to draw a sketch of the plot that you're using, and then make the comment about the normal probability plot looks roughly linear, so normality is okay.
Do you suggest disregarding confidence intervals and tests for means when sigma is known?
Yes, I do. Who asked that good question?
Melissa.
Yeah, and in fact, if you take a look in the fourth edition of the Practice of Statistics, you'll see that we've really diminished the role of sigma known, other than at the setup stage where you're learning about how it connects to the sampling distribution. In practice, you use T for means and Z for proportions, and that's really a time savings if you don't have to go through inference for means once with sigma known, which is really more of a pedagogical device. It isn't something you do in real life, and right now we don't have time to do pedagogical devices. We want to teach them the T procedures.